All right. In this video, we're going to review uh, the section 4.4, the method of undetermined coefficient. So last time, um, yeah, we did build up the the method. Okay, I mean we did derive the method, and then we saw just one example in a textbook. So, but today we're gonna see a couple of examples of the method. Okay, and then we're gonna move to section 4.7. So here, let me just take let's take a look at my lecture note. Okay, so here, what we did, what's the method of undetermined coefficient? So depending on the type of the external force, we're gonna guess the form of a solution. Okay, so that's a main idea. And then as you can see right there, give me a second. See, yeah, as you can see that if the external force is just monomial, then solution has a form like this. And then a solution, I mean, external force has the form the monomial times the exponential function, then a solution has the form like that. T to the s power and then polynomial times exponential function. Here the m degree of the polynomial is given in the external force. We can figure out that, and then r also given in the problems. You see that right there, r. So and then what about s? The the yeah. So see that here s. That's really important. To figure out s, we have to find out root of associate Ox equation. Why? Because the probably the without t to the s power, this is going to be a solution of the homogeneous difference equation. So it shouldn't happen, right? If this guy is a solution of the, let's just ignore t to the s power, and then this guy is solution of homogeneous difference equation associated with this, then we never get that external force when you plug in this one into the differential equation. So to avoid that bad situation, we need to multiply it by the t to the s power, and then that s will be determined by the root of the associated Ox equation. So associated Ox equation, nothing but Ox equation of the homogeneous equation associated with this non-homogeneous differential equation. So we're gonna find out the root of the associated Ox equation if r, you see the r here, if r is equal to the root of the Ox equation, then s must be 0. Is not equal to a root of Ox equation, s is 0. It means that we don't need t to the s power. Okay, and then simple root, s must be 1. A double root, s must be 2. Okay, and the third case, yeah, and then clear. Yeah, and then the third case, what if the external force has the form like this? Polynomial times, monomial times exponential function times trigonometric function. Then the solution has a form like that. It's kind of, yeah, I know it's really long, but normally in practice, the examples and test problems or quiz problems, in practice, most of case t must be 0, 1, I think up to 2. Again, you don't have to worry about that. It's not going to be like that long in real problems. Okay, so now so let's see example 1. In this lecture there are many examples shown, but I told we don't have enough time, so I'm not going to cover all the examples in the lecture note. Okay, please look at the examples that what I'm not going to cover by yourself. Okay, so we'll see this one. So find the particular solution to this. So you see that source function, monomial times exponential function. Yeah, so we need to figure out then a solution of the form must be this, right? T to the S power and the polynomial times A to the RT, and then we figure out S and M and R, right? Okay, so right here. So what is R? -1. Why? Because you see that here. Let's see, coefficient of T in an exponential function and source function, -1. So R must be -1. And then what is M? M is 1. Because you see that the degree of monomial in an exponential external force is 1. So M must be 1. So what about S? Yeah, to find out S, we need to solve the Ox equation, right? So this is the Ox equation, and then yeah, just do R algebra, then R gonna be 3 and -1, right? So we got two roots, which means that these are simple roots. So then see the R, keep in mind this, that R, do not confuse with this R and that R, okay? That this R comes from the what? I told you, from the external force, okay? And this R means what? The root of Ox equation, okay? Do not be confused. So as you can see, the -1, that is the exactly same as what? This R, right? Okay, right? Oh. So then what? S must be 1, okay? So S must be 1. So now then, step 4, so we figured out M, R, and S, right? So we substitute M, R, S into the form of the solution. So we got this, right? So here. And then what? We're going to plug in YP into the non-homogeneous differential equation to figure out undetermined coefficients, A1, A0, okay? Right? So A1, A0. So now then, yeah, and then next one, I know is it could be really tedious. So we find out derivative YP and then second derivative YP. Okay, let me skip it because this is nothing but just the base just algebra and calculus. So okay, and then once we figure plug in once we figure out YP prime, which is this, and then YP double prime, which is this, right? Okay, and then simplifying, we got this right there, right? So now then, plug them into the non-homogeneous differential equation, left-hand side of non-homogeneous differential equation. And finally, we're going to get this. Let's see. A second. Right there. Okay. So we see that here. Right. So now, oh, sorry. Okay, now we're gonna compare each like terms. Okay, pair of like terms. So definitely what t square is not in the, see that here, t square is not in the right hand side. So -3a, a1, what was this? By the way, you see the a1 plus 2a1 minus 3a1 0, right? And then simplifying this, we're gonna have let's see, -8a1 must be 3, and then the constant term must be 0, right? Okay, so we're gonna get system of equation for a1 and a0. So we solve it, then we're gonna get this. A1 is 3 over -8, and the A0 is -3 over 16. Yeah. Okay, so we got particular solution right there. Okay, so Now then, similarly, in the second example, we do the same thing. Okay, so the first one, look at the type of the source function. And then we figure out the form of the solution, and then find determine S, M, alpha, beta, and then find the root of Oxford equation. Okay, and then they compare this alpha and beta, alpha plus I beta with the root of Oxford equation. Look at the step 3. In the step 3, the alpha is 0, beta is 2, and then the root of Oxford equation 0 plus 2i. So 0 plus alpha plus I beta is matched with what? The root of Oxford equation. So S must be 1. Okay. Then so once we figure out that once we figure out the particular solution with the undetermined coefficient, to figure out undetermined coefficient, we plug in yp into the differential equation. Okay, find the yp prime, yp dot prime, and then compare the left hand side and right hand side, the differential in the non-homogeneous differential equation. Okay, then we're gonna get the system of the undetermined coefficient, system of equation for undetermined coefficient. Okay, and then we can figure out the y1, y0, b1, b0, which are undetermined coefficient. Okay, that's a solution, particular solution, I mean. All right, so now then 4.5, the superposition principle. Okay, so what you're gonna do, so far what we did is to just find out a solution of non-homogeneous differential equation. But our goal is to find out real particular solution of initial value problem. Okay, to do that, we need to find out general solution of the non-homogeneous differential equation. Okay, so to construct the general solution of the non-homogeneous differential equation, we need to understand the superposition principle. Okay, so what's the superposition principle? Let y1 be a solution to the differential equation. Let y1 be the solution to the differential equation. Okay, like this. And then let y2 be the solution to that differential equation. You see that here? Right hand side, source function are different in two differential equations, right? First one is to f1, second one f2. Then k1y1 plus k2y2, which is a linear combination of two solutions, must be solution of what? The non-homogeneous differential equation with the linear combination of two source functions. Okay, this is really cool, the theory. So why? Because what if f1 is the source functions in a non-homogeneous differential equation, and what if f2 is a zero function? F2 is zero function. Then we can say that the general solution of that non-homogeneous you see that f2 is 0, so f2 is 0 here. Okay, so now then this differential equation turns out to be just the to be equivalent to the first non-homogeneous differential equation. And then setting k1 equals 0, then general solution of that non-homogeneous differential equation must be linear combination of solution of the non-homogeneous differential equation and solution of homogeneous differential equation. We can say that. So I know it's complicated, right? So we're gonna see. Don't worry about that. We'll see more clear later. So let's see. Here's the example. Okay, simple example. This is application of the superposition principle. So f1, you see that f1 of t equals 3, and then f2 is defined by 10 times e to 3t. And then y1, let's say y1 is solution of that non-homogeneous differential equation, and the y2 be a solution to that non-homogeneous differential equation. And then see that here? Find the particular solution to this one. See, negative 9t, actually what? This is equal to, this is nothing but negative 3 times 3, f1. And then 20 times e to 3t is nothing but 2 times f2, right? So let me turn to the discussion paper, okay? So give me a second. Yeah, so what we did, give me a second. Okay, so f1 is, in this example, f1 is f1 of t defined by 3t, and the f2t is defined by 10 times e to 3t, okay? So then f1 y1 is of t is 3t over 2 minus 9 over 4, and then y2t is equal to 1/2 e to the 3t. Okay, so now then y1 is a solution of, this is solution of this y second derivative plus 3y prime plus 2y is equal to f1 t. And then that's the solution of this differential equation, y the prime plus 3y prime plus 2y is equal to f2t. Okay, the question is to find the particular solution to this. To y dou prime plus 3y prime plus 2y is equal to negative 9t plus 20 e to the 3t, right? So see that here, y dou prime plus 3y prime 2y, this is exactly the same as the left hand side of each differential equations. And then look at the right hand side. Sorry, let me see that. Right hand side is what? Negative 9t plus 20t. This is equal to what? Negative 3 times f1 plus 2 times f2, which is a linear combination of f1 and f2, right? Then superposition principle says that the a particular solution of that differential equation must be what? Negative, yp of t is equal to negative 3 times y1 plus 2 times y2. Okay. So the next one, let's see. Next one, algebra problem with the superposition principle and the method of undetermined coefficient. So when applying the superposition principle into the algebra problem. So here, as you can see that for given algebra problem, see that algebra problem is given right there. Okay, and let's say yp be a particular solution. Okay, and then y1 and y2 are linearly independent. Okay, which means that Wronskian is not equal to 0. All right. So now to the associated homogeneous equation. Okay. So you got it. Yp a particular solution. We can find a particular solution using undetermined coefficient, right? Method of undetermined coefficient. Okay, and then we can find that y1 and y2, which are solutions of associated homogeneous equations, right? We did many times, right? Okay, so y1, y2 are what actually solutions of the associated homogeneous equation, right? You remember that when you find out the general solution of the homogeneous equation, we did find y1, y2, right? So these y1, y2 are, yeah, these y1, y2 are, yeah, the y1, y2, what we did find, what we did, when you find out general solution to homogeneous equation. All right, so now then we construct the y as like this: yp plus c1, y1 plus c2, y2. See that here, c1, y1 plus c2, y2. This is a general solution of the associated homogeneous equation, right? The yp, this is solution, particular solution of a non-homogeneous differential equation. We know how to find it, find out that one using the method of undetermined coefficient. Okay, so I'm not gonna okay, explain again. Okay, so I did many times. Then this gonna be what? Yt. T. This one is what? Unique solution to integral problems, right? Okay, unique solution. So what that means? So this is actually a general solution of the what, non-homogeneous differential equation, and then using the initial conditions, uh, we can find, using initial conditions, we can find the C1 and C2, right? Then this is gonna be the unique real particular solution to the integral problems. That's what theorem says. Okay, so we're gonna use this theorem with the superposition principle, the method of undetermined coefficient, to solve integral problem of second order non-homogeneous differential equation. Okay, so all right. So I'm gonna give, we'll see example. This is the example, okay, and then just call it a day. Okay. So find the general solution to, yeah. Let me yeah. Okay. So give me a second. Yeah. Okay. So find the general solution to y double prime minus y equals t squared plus 1. So then with the two initial conditions right there, right? So step 1 is what? Therefore, we gotta find the particular solution. Okay. Then after that, we're gonna find out the general solution to the associated homogeneous equation, and then combine them, and then find out C1 and C2, uh, the unknown constants of integrations. Then we'll get the what, solution, particular solution of the integral problems. Okay, that's a strategy. So the first one, since you see that here, the type of the external force is the second order, second degree polynomial. Then what the form of the particular solution must be second order polynomial, right? Okay. So we're gonna figure out, we need to figure out A2, A1, A0, A1, A2, which are the unknown undetermined coefficient, right? So now then, let me see. Okay. So now then, yp prime, we're gonna find out yp prime, yp double prime, and then plug them into the differential equation. Okay. So then we're gonna get this t. We see that here, negative. Can you see that here? Doing a little bit algebra, we got this, right? So now then, the a, definitely a negative a2. I mean, at must be negative a2 must be 1, right? The negative a1 must be 0, because you see, in an external force, there is no the t term, right? Okay, and the constant term is 1. It means that 2a2 minus a0 must be 1. Okay, so a2 must be a negative 1, a1 must be 0. Okay, then a0 must be negative 3. So we got particular solution. Now, next step is to find the general solution to the associated homogeneous equations. Let's say YH. Okay. So we're gonna find the Ox equation first. Okay. So we see Ox equation must be r squared minus 1 equals 0, right? Then r must be plus minus 1. We got simple root. Okay. So YH, I mean general solution must be C1 times e to t plus C2 times e to negative t. It's not a big deal, right? So I'm sure that you be really really familiar with that, the step 2. Okay, so if you don't get it, how to find you struggle with find the general solution of homogeneous equation, please go back to the chapter section 4.2 and 3. Okay, so now step 3 is combine yp and yh. Okay, you see that here, yp plus yh, which is this, that's gonna be general solution of the non-homogeneous differential equation given in the problem. Okay, so now then we find this particular solution of initial problem using the initial conditions. Okay, so y0, plug in 0, you see the plug in 0 into t in our general solution right here, 0 0 and then 0 0. Okay, then we got this c1 plus c2 minus 3 equals 1. Okay, and then we find out the derivative of y, because to impose y prime 0 is 0, we need to find out the derivative y, right? Then y prime is this, and then plug in 0 into t, here 0 0 0 0. Okay, then we got this c1 minus c2 must be 0 by initial condition. So we got two equation for c1 and c2 linear equation. Okay, so solve the system, then we're gonna get particular solution finally. Okay, so please look at the examples in section 4.5 in textbook. Okay, keep in mind this. Okay, and the next time I'm gonna solve the one more examples in 4.5, and then we're gonna go to the 4.6. Okay, so thank you.